In the previous video, we had given the introduction to inverse trigonometric functions. There are some very important results and properties related with inverse trigonometric functions. Let us discuss those important properties and then we will write and discuss some important questions of this chapter. Now, the first result of this chapter is what is sine of sine inverse x? What is sine of sine inverse x? Answer is it is always equal to x for x belonging to closed interval minus 1 to plus 1. For x belonging to closed interval minus 1 to plus 1. Now the question is, what is sine inverse of sine x? Sine inverse of sine x will be equal to x only if x belongs to closed interval minus pi by 2 to pi by 2. Sine inverse of sine x is also x if x belongs to minus pi by 2 to pi by 2. Remember, sine of sine inverse x is a number, but sine inverse of sine x, it is a periodic function. This is periodic function. Similarly, cos of cos inverse x, it is equal to x for x belonging to minus 1 to plus 1. But cos inverse of cos x, this is equal to x only if x belongs to 0 comma pi. Cos inverse of cos x is a periodic function. Okay. Third one, tan of tan inverse x is equal to x for x belonging to minus infinity to plus infinity. But tan inverse of tan x is equal to x only if x belongs to open interval minus pi by 2 to pi by 2. Fourth one, cot of cot inverse x is equal to x for x belonging to minus infinity to plus infinity. Cot inverse of cot x is equal to x only if x belongs to open interval 0 comma pi. Okay. Fifth result, secant of secant inverse x, it is equal to x for x belonging to minus infinity to minus 1 union 1 to infinity. Union 1 to infinity. And secant inverse of secant x is equal to x if x belongs to 0 comma pi by 2, 0 to pi by 2, closed at 0, open at pi by 2, union pi by 2 to pi. Just see the difference in the two. Sixth result is cosecant of cosecant inverse x. cosecant of cosecant inverse x is equal to x if x belongs to minus infinity to minus 1 union 1 to infinity. Union 1 to infinity. Whereas cosecant inverse of cosecant x is equal to x if x belongs to minus pi by 2 to 0 union 0 to pi by 2. So observe the difference in this first result. In this first result, just see the difference. Now second result. Second result. Sine inverse of minus x. Sine inverse of minus x is always equal to minus sine inverse x. Is always equal to minus sine inverse x for x belonging to closed interval minus 1 to plus 1. Cos inverse of minus x. Cos inverse of minus x is equal to pi minus cos inverse x. For x belonging to closed interval minus 1 to plus 1. Tan inverse of minus x is equal to minus tan inverse x for x belonging to minus infinity to plus infinity. Cot inverse of minus x is equal to pi minus cot inverse x for x belonging to minus infinity to plus infinity. Secant inverse of minus x is equal to pi minus secant inverse x for x belonging to minus infinity to minus 1 union 1 to infinity. Cosecant inverse of minus x is equal to minus cosecant inverse x for x belonging to minus infinity to minus 1 union 1 to infinity. This is our second result of inverse trigonometric function. Now the third result is sine inverse x is always equal to cosecant inverse 1 by x, provided x belongs to minus 1 to 0 union 0 to 1, excluding 0. Excluding 0. In this second result is cos inverse x. We can write it as secant inverse 1 by x for x belonging to minus 1 to 0 union 0 to 1. Union 0 to 1. Third result is tan inverse x is always equal to cot inverse 1 by x for x belonging to 0 to infinity for positive real numbers, and it is equal to minus pi plus cot inverse 1 by x if x belongs to minus infinity to 0 for negative real numbers. And in this only, the fourth result is cot inverse x is equal to tan inverse of 1 by x for x belonging to 0 to infinity, and it is equal to minus pi plus tan inverse 1 by x for x belonging to minus infinity to 0. This is our third result. Now the fourth result, very, very important, sine inverse x plus cos inverse x is always equal to pi by 2. Sine inverse x plus cos inverse x is pi by 2 for all x belonging to minus 1 to plus 1. Okay. Second result in this is tan inverse x plus cot inverse x is also equal to pi by 2 for x belonging to minus infinity to plus infinity. And in this third result is secant inverse x plus cosecant inverse x is also equal to pi by 2 for x belonging to minus infinity to minus 1 union 1 to infinity. Okay. Now in this, let us write the fifth result. In this fifth result is sine inverse x. Sine inverse x we can write in terms of cos inverse as root of 1 minus x square. We can write in terms of tan inverse as tan inverse of x by root of 1 minus x square, provided x lies between 0 and 1. X lies between 0 and 1. In this second result is cos inverse x is always equal to sine inverse of root of 1 minus x square. It is equal to tan inverse of root of 1 minus x square by x for x lying between 0 and 1. And in this third result is tan inverse x is always equal to sine inverse of x by root of 1 plus x square, which is equal to cos inverse of 1 by root of 1 plus x square if x is greater than or equal to 0. This is your fifth result. Now in this sixth result is if x lies between 0 and 1, y is also between 0 and 1, then sine inverse x plus sine inverse y is always equal to sine inverse of x into root of 1 minus y square plus y into root of 1 minus x square. Y into root of 1 minus x square for x square plus y square less than or equal to 1. For x square plus y square less than or equal to 1. In this second result is sine inverse x minus sine inverse y is always equal to sine inverse of x into root of 1 minus y square minus y into root of 1 minus x square. Third result in this is cos inverse x plus cos inverse y, cos inverse x plus cos inverse y is cos inverse of xy minus root of 1 minus x square into root of 1 minus y square. For x square plus y square less than or equal to 1. And cos inverse x minus cos inverse y is equal to cos inverse of xy plus root of 1 minus x square into root of 1 minus y square. Okay. Now after that, the next result is seventh one. For x greater than 0, y greater than 0, first result, tan inverse x plus tan inverse y is always equal to tan inverse of x plus y divided by 1 minus xy if xy is less than 1. If xy is less than 1. It is pi plus tan inverse of x plus y by 1 minus xy if xy is greater than 1. If xy is greater than 1. And it is exactly pi by 2. It is exactly pi by 2 if xy is equal to 1. It is exactly pi by 2 if xy is equal to 1. And in this fourth result is if x and y are of same signs, then tan inverse x minus tan inverse y is equal to tan inverse of x minus y divided by 1 plus xy. X minus y divided by 1 plus xy. This is our seventh result. Now eighth result is 2 sine inverse x. 2 sine inverse x is always equal to sine inverse of 2x into root of 1 minus x square, and it is cos inverse of 1 minus 2x square. Okay, this is the first result. Second result in this is 2 cos inverse x is always equal to cos inverse of 2x square minus 1, which is always equal to sine inverse of 2x into root of 1 minus x square. And in this third result is 2 tan inverse x is always equal to tan inverse of 2x by 1 minus x square, which is equal to sine inverse of 2x by 1 plus x square, which is equal to cos inverse of 1 minus x square by 1 plus x square. Okay, this is your 8th result. This is our 8th result. 9th result in this is 3 sine inverse x. 3 sine inverse x is equal to sine inverse of 3x minus 4x cube. Okay. First result. Second result in this is 3 cos inverse x is always equal to cos inverse of 4x cube minus 3x. 4x cube minus 3x. And third result in this is 3 tan inverse x is always equal to tan inverse of 3x minus x cube by 1 minus 3x square. This is your 9th result. And the 10th result in this is tan inverse x plus tan inverse y plus tan inverse z, tan inverse x plus tan inverse y plus tan inverse z is always equal to tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz minus zx. 1 minus xy minus yz minus zx. Now in this second result is if tan inverse x plus tan inverse y plus tan inverse z plus tan inverse z, if it is always equal to pi by 2, it is always equal to pi by 2, then the condition is xy plus yz plus zx is always equal to 1. Is always equal to 1. And in this, the third result is if tan inverse x plus tan inverse y plus tan inverse z is equal to pi, then x plus y plus z is always equal to xyz. Now these are some very, very important results of inverse trigonometric functions chapter. Now we can prove all these 10 results. We can prove all these 10 results. The proof of all these 10 results are there. If anybody is interested, the proof of any of these 10 results, they can put in their comments. We can prove these results, if possible, one by one. So in our next video, we'll try to discuss problems of inverse trigonometric functions based on these 10 results.